identify the zeros of the function. This is a polynomial function. Remember that the equation is going to be polynomial as long as two things aren't happening. The exponents can never be negative numbers, and you can never have a variable in the exponent position. So the first thing they ask us to do is to find the zeros. And yes, you could do this on a calculator, but the test is specifically going to say you need to do it algebraically. And here's how we do it. If you ever want to look this up, it's called synthetic division. And as with most things in math, it seems like some students catch on to this after the first problem, and other students it takes several days. So if you need to see more videos, feel free to Google synthetic division. Here's how synthetic division works. We want to find three answers. Let's review what we learned last week. Last week, before you took the Unit 3 exam, we talked about the degree. This is a degree 3. Degree 3 means you could have a maximum possible of 3 real solutions. Again, I want to emphasize maximum possible. Or you could have a maximum possible of 2 complex and 1 real. And we say 2 complex because complex solutions come in pairs, like plus 2i and minus 2i. And how many pairs can I get out of 3? I can get 1 pair of 2. So that's why 2 complex. We need still to add up to 3 and there'd be 1 real. These are the possibilities. Right now I don't know which one it's going to be, but I'm going to determine that. So I'm going to circle the constant at the back and the sign that's in front of it. And I'm going to write down all of the possible real solutions. And the possible real solutions are going to be the numbers from 1 to 12 that nicely divide into 12. Plus or minus 1, plus or minus 2, 3, 4, 6, and 12. So there's 12 different options for me to try. And I know that at least one of these, at least one will be a real solution, or I'll be able to find 3 real solutions. When you find a solution, remember, let's talk about the word solution. What are other words for solutions? X-intercepts, roots, another one? Zeros, okay? The key is the word zeros. When you find one that works, there's a couple different ways I'm going to show you how it works. But when you find one of the numbers that works, when you substitute it in for x and you solve on the right-hand side, you're going to get y equals 0. That's when you have one that works, okay? So this would be the really slow way of working this. And I'm not going to teach you to do it this way, but know that this way works. You could take positive 1. Then you cube positive 1, you go subtract 3 times 1 squared, minus 4 times 1 plus 12. If that value is 0, hey, you just found an answer. Thumbs up or thumbs down if you understand that. I'm going to teach you the method because you're required to show the method later on for another problem called synthetic division. Put your pencils or pens down. You're going to watch me do it 2 times. The 3rd time you'll do it with me. Here's how it works. You make it upside down division. You don't have to include the x's, but I like to include them so we don't forget about any numbers. So it's 1x cubed minus 3x squared minus 4x plus 20, or plus 12. So I've accounted for each of the spaces. I have x cubed, x squared, x the first, and the constant. Now I'm going to try the first number, so I'm going to try positive 1. If it works, what does this add up to again? If it works, I get a 0. When you plug these in, if you wanted to try it the slow way, if you don't get 0, you just know it's not an answer. It's not a solution. It's not a root, not an x-intercept. So I prefer to call this is not the mathematical term. I like to call this the MAMA method. And MAMA stands for multiply, add, okay? And you can do that as many times as you want in a row. As soon as you multiply, you must follow it up with adding. Every time we multiply, we'll multiply by the number out front. In this case, it's a 1. So your first step is to bring down the first number. You're just watching. Now we start with multiplying. 1 times 1 is 1. Now we go to A for adding. We add straight down and end up with negative 2. We go back to multiplying. We always multiply with the outside number. 1 times negative 2 is negative 2. Add straight down to get an answer of negative 6. Go back to multiplying. 1 times negative 6 is negative 6. Add straight down to get an answer of 6. Does this work? Is 1 a root, solution, x-intercept 0? The answer is no, because the final answer is not 0. So 1 did not work. I'm going to try -1. You're just watching the process. The next problem you'll do with me. Always bring down the first number as step 1. We always multiply with whatever's out front. So I'm going to start with mama, start with M. Multiply, add straight down. Multiply, add straight down. Multiply, add straight down. Does this mean that -1 is a solution, x-intercept, root, or 0? Nope, doesn't work, right? Okay, you're going to do the next one with me. So the next number on our list of possible real roots is +2. Please write down +2, upside down division box. Okay, step number 1, let's bring down the coefficient of 1. Everything we multiply goes back to the outside number of 2. So mama, multiply, add the rest of the way. Multiply, receive an answer of 2. Add straight down, get an answer of -1. Multiply, -2. Add straight down, -6. Multiply, -12, add straight down, 0. 1 through 5, how well were you able to follow that problem? 1 through 5 right now. Okay, most of us are 3s to 5s. Okay, so we have one answer, we can see it worked. Everybody write x equals 2. Here's why you want to use the synthetic method. It would take so long for you to then check -2, +3, -3, +4, -4, 6, -6, 12, -12. And that's assuming that the answers you have are only real. What if they were complex? That doesn't help you. So that's why we use a method called synthetic division. So notice the numbers I have on the bottom. I need to go to the next paper, but notice the numbers I have on the bottom. Here's what you're going to do. You write down 0 equals, and we're going to go backwards and make this trinomial. The first number in a trinomial is just the constant. Then it's the number that has just x to the first and x squared. With the help of your partner, I'm going to give you 20 seconds. I would like you to factor and solve this trinomial. Ready? Go. Okay, so what numbers multiply to get -6 and combine to get -3 would be x subtract 3 and x plus 2. What numbers multiply to get -6 and combine to give you a -1? It would be -3 and +2. We don't have to worry about bottoms up because the leading coefficient is a 1. So I'm going to circle the -3 and circle the +2. That means x equals 3 is our second real solution. Remember, words for real solution would be x-intercepts, real roots, real zeros, and x equals -2. So I have three answers, and come back up here. We had two options that were going to occur. I was going to get 3 real roots, or 3 real solutions, or 3 x-intercepts, whatever one of the words you want to substitute in here. Or you were only going to have 1 real solution and 2 complex that would have i's. What choice did we end up getting? 3 reals, right? Okay, so I do know that. Now, when you look at this, you can go to the constant, the number at the very back, and this will be your y-intercept. So at this time, you're going to make a pretty simple graph. I just want to make sure it goes up high enough to get to 12. And I'm going to start by graphing the y-intercept. Now this is going to be a rough sketch, so don't worry about it being like extra pretty. I'm just looking, I'll tell you for what 3 things I'm really looking for. So this is the y-intercept, and now I'm going to graph the 3 solutions or roots that I came up with. The first one we got was 2, and then the next 2 were positive 3 and negative 2. So when I'm looking to grade this on your test, one of the 3 things I'm looking for is, do you identify the roots and the y-intercept? Okay, now let's go back and let's refer to what you learned last week. Last week we talked about the degree, and we talked about things being even or odd and positive or negative. So the degree is the highest exponent. So this particular equation is odd degree, and the leading coefficient is positive. Turn to your partner and using hand signals, which one does this look like? Go. It should be your right hand up, left hand down. Are we good at that? I mean, I know that you just learned that once, now I'm expecting you to memorize it, but we're going to be using that a lot. So listen very closely. Right hand up. So go to the very right x-intercept and go straight up with an arrow. And we had our left hand pointing downward, so go to the very left x-intercept and go down. And yes, they both are at a diagonal, one going down to the left, one going up to the right. So the second thing you're going to get graded on is, are your end behaviors correct? On the right, are you going up, and on the left, are you going down? And the final thing you'll get graded on for this sketch is, are you able to do a rough graph that takes you from here to here to here correctly? For instance, I need to get from the left x-intercept to the middle x-intercept, and I have to also incorporate the y-intercept. So we're going to come up here, grab it, and come back down. And now I need to go from the middle x-intercept to the right. And so to do that, I'm going to go down and come back up. Problem done. Now, if you happen to go down further than I am, or your partner goes just a little bit down, I'm not grading on that. I'm just looking for the general shape. So we have identified the zeros. We've done a graph of it. Now I would like you on your own to write down formally what is the end behavior. Go ahead. As you go to the left, your function is headed down, and as you go to the right, your function is headed up. Can I have a thumbs up or down? Did you get that right, or did you not get that right? Okay, one last thing. If you had to fill in this blank, for this graph, we know we need to end up with an answer of 3. So whatever you put into these blanks needs to add up to 3. Of the solutions, how many of them were real? 3. How do you know that? 1, 2, 3. So if 3 were real, that means there was 0 complex, since your final answer has to add up to 3.